Hi everyone, and thanks for taking the time to watch this AWS Summit session. My name is Nieves Garcia. I'm the Artificial Intelligence and Machine Learning Specialist for Public Sector across Asia Pacific and Japan. And I have the pleasure to have with me today Emily Loader, Director of Transport Operations for the Department of Transport Victoria. She is going to present us their specific use case for AI to improve safety for our communities, reduce emergency services response time, and increase real-time visibility and operational efficiency. To start, I want to show you some data on the progression of machine learning. According to IDC, the global spend on enterprise artificial intelligence and machine learning went from virtually zero in 2013 to $50 billion in 2020. That is just 7 years. By comparison, cloud computing went from zero to $50 billion in 12 years. That is almost twice as long as machine learning. Now, this investment in machine learning is happening because it will help us to improve important economic and social issues. As artificial intelligence matures, use cases evolve, and requirements start to expand from very niche to everywhere at any time. I would like to spend the rest of the time in this presentation to go through what's next in AI/ML, in particular, bringing machine learning to the edge. So, what is AI? Put it simple, AI addresses the processing and the implementation of machine learning algorithms locally on the device that collects the data. This reduces any network delay for data transfer and solves security and privacy challenges as everything happens on the device itself. There are 4 drivers, edge computing and AI, that we need to consider. I propose here a framework with questions you can ask yourself when thinking what's best for your use case. First, ask yourself, do you need real-time decision-making? Second, what privacy and security requirements do you need to consider? For example, do you need to de-identify or anonymize information at the edge? Or does information need to stay in a particular location or country? The third and fourth question will be, how reliable and convenient is the connectivity in your environment? Some customers really operate in environments where there are bandwidth constraints related to cost or infrastructure or simply intermittent connectivity. And in these instances, it's either very expensive to send high bandwidth video streams, for example, to the cloud, or customers simply don't have sufficient bandwidth to do it. They will prefer to be able to process all of that video data at the edge and then send selected data back to the cloud. As a result of these drivers, customers are looking for a solution that allows them to capture and process data, such as image and video, where it resides, at the edge. And the most obvious use case is the autonomous car. It requires real-time decision-making at any time without dependencies with network connectivity and with milliseconds latency. Similarly, we can think about other urgent situations. For example, if there is a danger involved, like a surfer being approached by a shark, or an intrusion, or a potential accident, or a suspicious item in a public space. We can think also about remote locations where internet connection may be intermittent or expensive. Imagine monitoring applications in the outback for road safety and maintenance, or agriculture, pest detection, or smart irrigation. There are also some industrial scenarios where you want to monitor defects and detect anomalies in real time immediately, so you can adjust the production processes based on it. And it's not only real-time, anywhere or anytime what's driving AI, privacy assurance is another factor. Here in Amazon, we rapidly applied it ourselves during COVID-19. AI-powered solutions were deployed to deliver accurate information in real time about staff body temperature and distance measurements. These solutions help to promote policy attainment and healthy workspaces, preventing the virus to rapidly spread. And we look at AI as a way to ensure that real-time insights while also securing the privacy for our staff. In AWS, we really believe that most applications requiring Edge AI are not going to actually be only pure Edge AI. What we believe is that there will be a combination, partially being done at the edge and partially being done at the cloud. For example, in healthcare, AI-powered devices can be used to monitor locally our vital signs and health. By de-identifying directly the data in the edge, privacy is assured. But those algorithms need to have continuous feedback as new data arise and new technologies are developed. So actually customers are implementing a combined approach. They are de-identifying the data and delivering real-time response in the edge, and then sending anonymized data to the cloud for model continuous training and for complex algorithms that require more powerful underlying infrastructure to produce high accurate results. Let's see how this process looks like and how it compares to the AWS Cloud AI offer. On one side, we have Cloud AI. These are machine learning algorithms used in the cloud. The cloud provides on-demand infrastructure that can be used as required, optimizing return on investment and time. According to IDC, this form is still the mainstream, with 75% of the recent study respondents deploying machine learning on the cloud. On the other side is Edge AI. As we have discussed, Edge AI addresses the processing and the implementation of machine learning algorithms locally on the device that collects the data. In the same study, less than 10% claim to be using AI at the edge, being the rest in other formats such as on-prem. If we look at the growth rates, though, Edge is actually very promising, with an unprecedented demand in the last months, and we believe a hybrid concept of Edge AI, better balancing the requirements of the edge with the power, flexibility, and convenience the cloud provides, can even further accelerate the motion. In our recommended model, in both cases, training data will come from the devices to the cloud, either periodically or trigger-based. The difference is where the inference, or in other words, where the model output happens. In the cloud AI, both training and inference happens in the cloud, so the device is dummy, just collecting the information and sometimes obtaining the inference from the cloud. In the case of the Edge AI, the training model is what's downloaded to the edge, so the inference can be run in the device itself and produce an outcome with the new data directly from that end device without requiring uploading the data to the cloud. This Edge AI balance model helps to have the best of both worlds, leveraging on the device for real time, anywhere at any time, and privacy assurance, while relying on the cloud for more power-intensive and overall model training continuity, even if it's only periodically or when conditions allow. AI at the edge, and in particular computer vision, cover a large number of use cases, as you can automate a large number of visual inspection tasks. For example, Fender uses AWS Edge AI to optimize their high-quality guitars manufacturing efficiency, identifying anomalies and enabling them to take quick corrective action. On the other side, Parkland is leveraging computer vision to deploy different applications on their stores and strengthen their customer experience. In Amazon, as a larger group, we use computer vision for efficiency in our logistics, from finding the right packaging or automating the warehouse or speeding up the last mile delivery. Examples are very diverse. While we won't have time to discuss all of them, today I'd like to invite Emily to hear from her how the Department of Transport Victoria is leveraging Edge AI here in Australia. Welcome, Emily, and thanks for sharing with us your story and how Edge AI can transform transportation.
Hi, I'm Emily Lotter, the Director of Transport Operations at the Department of Transport here in Victoria. My team is responsible for the 24/7 operation of 23,000 kilometres of freeways and arterial roads that make up our state road network, which serves over 5 million people in Greater Melbourne and a further 1 million people in regional Victoria. I'm excited to be here with you today to talk about our $340 million Smarter Roads program and how we're using AI at the edge and AWS Panorama to transform the way we manage congestion. So how are we using AI at the edge? I'm going to set the scene by walking you through our transport challenges and current operating environment. The primary driver of worsening congestion on our roads pre-COVID was population growth. As seen in other capital cities in Australia and around the world, COVID has significantly changed how people use the network. We've seen chronically depressed public transport patronage as low as 25% and still way below pre-COVID levels, and a corresponding increase in demand of private vehicle use on the roads, particularly the arterial roads. Our ability to manage this new and dynamic demand has been limited by my team's greatest challenge, a lack of real-time situational awareness. Through Smarter Roads, we've started to improve our situational awareness by installing more on-road assets. We've recently added over 700 CCTV cameras to a total of 1,200 across the arterial road network, giving us visibility of roads where we had no data or vision before. We have thousands of sensors on the network, including Bluetooth, in-road sensors, roadside laser and radar. We also now benefit from new data sources from Here and TomTom, and we fuse these with our sensor data to greatly enhance our understanding of network performance. This is a huge leap forward for the department, but all of this data is accessed through multiple operational systems, and many can't be accessed in real time. This inconsistent and incomplete access to real-time information means our operators are working reactively, manually overlaying information sources and relying on phone calls from the public and emergency services to prioritise responses and measure impacts. They do an incredible job in this environment, but to meet our transport challenges, we need to move from our reactive operating model to proactive management of the network. The Victorian Government funded Phase 1 of Smarter Roads in 2020, 6 months into the COVID pandemic. It's a $340 million investment over 4 years for more frontline operational staff, on-road assets, systems and data to transform our management of the road network. It's a staged implementation, initially focused in 3 geographic areas with plans to roll out to the rest of the network. Smarter Roads was conceived over 5 years ago and originally designed to deal with growing demand to population growth. The impact of long-term depressed public transport usage and the critical pressure this would create on the arterial road network was anticipated early in the pandemic. The key to managing this and to deliver smoother, more predictable journeys in our new normal is situational awareness, and the key to situational awareness is optimal reality using AWS Panorama. Our most critical situational awareness tool on the road network are our 1,200 CCTV cameras. They enable quick validation of traffic conditions to support real-time decision-making, but our use of these assets is limited. The only way to glean information from a CCTV camera is for an operator to manually select and watch the live stream. During peak periods, less than 15% of CCTV cameras are used by the operations team, so at any point in time there's around 1,000 cameras just gathering dust. To gain comprehensive situational awareness, we need to be smarter about how we use these assets. Deloitte is doing this with AutoEye, a video analytics solution and critical component of optimal reality that is powered by AWS Panorama. The overall goal of AutoEye is to use the department's existing CCTV camera network as sensors, generating additional value from these assets by autonomously detecting and prioritising incidents before notifying operators. The AutoEye video analysis pipeline has 5 distinct phases, starting with detection. Using AI at the edge, AWS Panorama will analyse all 1,200 live video feeds in real time. This hasn't previously been possible at this scale. AWS Panorama devices are providing the required computational power within the DOT network, ensuring data speed and privacy. The second phase is tracking detected objects over time, where machine learning will enrich the dataset with vehicle behaviour information. Then we move on to analysis and identification. Here, machine learning will enable identification of specific incidents of interest and general abnormal behaviour from the enriched data and baselines. And this last one is a game changer, the notification to our operators. It enables more focused, proactive incident response by providing operators with notifications and supports decision-making and prioritisation. And at this point, AWS Panorama is collecting data and delivering insights from the 1,000 CCTV cameras that were not previously being used at any given moment. And this is truly transformational. With this capability, we will know about more incidents more quickly, which will result in faster responses and recovery. For example, a truck rollover, a significant incident that we see regularly on our freeways. Congestion builds extremely quickly around these scenes, with road closures in place for hours, and there's a high risk of secondary incidents occurring on the approach and in the surrounding network. These are really difficult to detect while our operators are actively coordinating incident response at the scene with on-road teams and emergency services, and can compromise safety and compound delays. Likewise, during storm events, the volume of network disruptions increases considerably due to incidents and flooding. Automated detection of incidents will enable operators to act more quickly and focus on the highest impact incidents, which will reduce the impact and delays, speed up network recovery, and save people time on the road. The uplift in operational capacity as a result of AWS Panorama and machine learning capability will be significant. You can see here an open source example of the tracking and analysis capability. This is the foundation to enable the department to move from reactive to proactive network management. I very much look forward to sharing the product and the results with you once it's in operation next year. Thank you.
Thanks, Emily. It's great to hear how you are leading a world-class innovation in this area. The final part of this session is really to show you how AWS capabilities can help. AWS can help you to accelerate your machine learning at the edge projects. In 2017, we launched the AWS Deep Lens device, designed to give developers hands-on experience with computer vision through a machine learning-enabled webcam. AWS Deep Lens is perfect for fast-track your computer at the edge experimentation. Once you move into production scenarios, or if you have existing CCTV footage, then AWS Panorama will be a better fit. AWS Panorama is an end-to-end computer vision at the edge platform that can automatically discover and connect your existing IP cameras to run multiple machine learning models. AWS Panorama helps our customers to automate a variety of tasks, from detecting, counting, tracking movement of objects, to classifying objects based on color, condition, and type, measure distance and proximity, read text and numbers, recognize gestures and physical activities, or many more. You can experiment with one of your models in our example library, or bring your own model, or acquire one of the AWS Partners Community ones. AWS Panorama helps different industries to yield new operational insights and automate business processes. And we've seen today how Department of Transport Victoria uses AWS Panorama to bring intelligence into our roads. Customers are increasingly asking us to bring more and more pre-trained AI services to the edge. Our latest addition is Amazon Lookup for Vision at the Edge, a machine learning service that improves industrial production quality and operational efficiency by identifying visual defects or anomalies. It is an AutoML service, so with as few as 30 images, you can train a model to automate visual inspections, saving you time and money. A good example is how Duff Guards, a producer of pizza, uses Amazon Lookup for Vision to ensure their pizzas have the right quantity of toppings so we all can enjoy high-quality pizzas. Finally, with your computer vision for any model, we have Amazon SageMaker that can help. With Amazon SageMaker, you can build your model once and optimize it and deploy it either in the cloud or in the edge without degrading the model performance. Amazon SageMaker helps you to automate the operational maintenance over time for different models and over a fleet of devices. In particular, Amazon SageMaker Neo automatically optimizes machine learning models at the edge to perform up to twice the speed with no loss in accuracy. And if what you have is a fleet of devices, such as smart cameras, robots, personal computers, and mobile devices, then Amazon SageMaker Edge Manager helps you to optimize, secure, monitor, and maintain machine learning models in fleets of edge devices to ensure that your models are deployed and operating correctly. So now is your time to get started. I hope you have enjoyed the session and can walk away from it with some takeaways. To summarize it all, AWS can help you to accelerate your machine learning at the edge projects. We've seen how, for example, Department of Transport Victoria uses our end-to-end computer vision at the edge platform Panorama to bring intelligence to our roads, moving from a reactive to a proactive approach that can save lives in our roads with faster assistance. Please check the resources available in this presentation you can download, and don't hesitate to contact our team for support. If you want to learn more, we encourage you to get engaged with our training and certification content today. And with this, I just want to thank you again for taking the time to join us today, and feel free to connect with Emily and myself on LinkedIn if we can help you. If you liked this session, please share what was your favorite part in our survey and enjoy the rest of the summit.